Hi guys, today's video is going to look at how to solve systems of equations using the substitution method. Now if you look, I've already set up an answer key, and below that I have the general steps to how to do this with any system of equations, okay? So in this case we have two equations that form our system. We have 2x plus 5y equals 20, and we have x minus y equals 3. And in step 1 it says we have to solve one equation for a variable. Now, it doesn't matter which one we choose. We could use equation number 1 or equation number 2, and you'll still get there. However, there is a choice that I would prefer for you, and that is work smarter, not harder. Choose the easy way, all right? So in that case, if you just look at them for 2 seconds, you should be able to see that equation number 2 is going to be much easier to work with to solve for a variable than equation number 1. All right, so let's put that up there in our workspace. So we have x minus y equals 3. Okay? To solve this, it's one step. You just add y to each side. These two cancel out, and you have x equals y plus 3. And I'm also going to put that down here below step 1 just to keep track of it. All right, so x equals y plus 3. Now our next step says to substitute the variable in the other equation with the expression you found in step 1. All right, so we're going to take our x equals y plus 3, and we're going to go ahead and substitute that in for the x's in our first equation. All right, so there's only one x, which is nice and easy. So we have 2 times y plus 3 for the x. Here's the substitution, plus 5y equals 20. Distribute the 2 to both terms in the parentheses, and you have 2y plus 6 plus 5y equals 20. Now we have to go ahead and add our like terms. So you have 2y and you have 5y. Add those together, you have 7y plus 6 equals 20. Now we just use the basic moves of algebra to solve the equation for variable y. Subtract 6 from each side, 7y equals 14, divide by 7 on each side, and you end up with y equals 2. That is part of our final answer. We have one portion of the coordinate pair. So y is 2. But we're not done yet. We still have to find the final answer for x. We found an expression for x, but we need to find the specific value for x that makes the two equations true. So how do we do that? Now we just take the y that we found and we plug it in to one of the equations. Now once again, take the easy way out, all right? You have those two equations, it'll work in either one, but use the easy one, and that's going to be equation number 2 again. So you have x minus y, or in this case we found it to be 2, equals 3. Once again, we have a one-step equation. Just add 2 to both sides. You have x equals 5. So now we found our x coordinate. And we'll plug it into our answer. Now, are we done yet? No, we are not. There's one more thing we need to do, and that's check our answer, because it's very easy to make a mistake when you're going through multiple equations. And if you want to catch that mistake and get the right answer at the end of the day, you'll just want to make a double check. And to do that, you just plug both variables into both equations. So let's go with equation number 1. So 2 times x, which is 5, plus 5 times y, which is 2, equals 20. If we simplify that, we have 10 plus 10 equals 20. And then simplify again, you have 20 equals 20. Is that true? It sure is. That means the coordinate pair 5, 2 is correct, is true for the equation 2x plus 5y equals 20. So now we're going to go ahead and do that same thing with the other equation, and it'll be much faster. So we have x, or 5, minus y, or 2, equals 3. Is 5 minus 2 3? You betcha. And so x minus y equals 3 is also true for the point 5, 2. And that is our final solution. We've now found our single coordinate pair where each one of those equations is true. So good job, guys. You can apply these steps to any equation or system of equations you need, and they'll help you find your answer. Good luck, and thanks for watching.